Okay. Okay, we're good. So the first thing, integrals are taking derivatives backwards. Okay. So the power rule is this: the derivative of x to the n is equal to n times x to the n minus 1. Right? Since we want the derivative, what we are basically looking for is this function. This is the original function. Okay? When we take the derivative of that, we get x to the n. Okay? So let me just show that. If we were to take the derivative of this, we would get, did I say that right? Okay. If you took the
n minus 2.
Sorry, yeah. The original function is x to the n. Okay. So the original function is x to the n. And we take the derivative of it to get this. Okay? If we were given this, how do we find the original function? So that's where integrals come in. Okay? So it's the whole idea of trying to get the original function because we know what the derivative is. So just by trying to isolate x to the n minus 1, we get d over d of x to the n over n. This is a proof that they have in Dino, which I'm trying
Why
to.
is it x to the n over n?
So now what we have is what the derivative was in terms of the original function in a weird way. Okay?
Basically divided it.
Yeah. So I isolated x to the n minus 1. I'm trying to learn what the proof is saying while doing this, but they explained this in the video. So we're going to let n equal to n minus 1. That means little n is equal to big N plus 1. Okay? Yeah, just bear with this, and then we'll get through this. Yeah. So we still have d over d of x. The x to the little n becomes big N plus 1 all over big N plus 1. Okay? You can think of the big N as the n we have over a derivative because it's minus 1. Okay? So we did the substitution. Like, this isn't that important, but n can equal -1 because it's divided by that. So when we do the integral, yeah,
When you replace the little n with
this is also equal to x to the big N. Okay? Now the other side is equal to x to the big N. That means x to the big N is therefore the integral of x to the n dx. I'll explain this in a second. Equal to x to the n plus 1 all over n plus 1 plus c. Okay. You guys understand up to this part? It's equal to x to the n. No? Sure?
Why are
Okay. the whole idea is trying to get this, okay, which is this. Trying to get that from this x to the n minus 1. So that's the proof, and they might explain that better in the video, but I'm going to do an example, and hopefully that will clear everything up. Okay, so let's start with x squared. This just tells us that taking the derivative of x to the n, we have to add 1 to the top and divide it by that exponent. Okay? This is a proof to getting that. X to the n plus 1, big N plus 1, is the same thing as a little n. So it's the same thing as that.
Oh, so there's actually like a way, like mathematically, you can have the integral of something, so you know how to get it other than just being good at looking at it.
Yeah.
Oh, that's good.
So looking at x squared, okay? So just doing the derivative of it, what do we get? 2x. Because we had 2 minus 1. Okay? If we were to take the integral of let's do x. Okay? That x is, so we need dx. That x is to what power? 1. This proof tells us that it's x to the 1 plus 1, so it's x squared over 1 plus 1, which is 2. Now we can't forget plus c, because the derivative of any constant is 0. So if we were to take a derivative of this, we would bring down the 2, we'd get x. Okay? So that's just x. Coming back to 2x, the derivative is 2x. Okay? Coming back to 2x, if we were to take the integral of 2x, you can't forget the dx. Okay?
What does that really simplify?
That's,
Just like proper.
yeah, but that came from this proof. Since we were dividing it by a dx here, we multiplied it to the other side. So it's x to the n dx. When you take a derivative of anything with a dx, that cancels out. Okay? So that means we're taking the integral of this function, which is, but you guys don't need to go that deep.
So you don't need to use it? Or
No, you do need to write dx and the integral sign.
You just write it like after everything.
Yeah. Yeah.
Right.
But it's like the
Fancy
same thing as like squaring a radical, right? It just like cancels them both out.
Yeah, but technically, when we took an integral of x to the n dx, we'd have an integral sign here, because we're doing integrals of both. And the integral of this would equal x to the n. Because
So
technically, and you guys don't need to know this, but you guys want to know it, the integral of dx cancels out, okay?
Okay.
But since we took an integral of this side, we need to do an integral of this side.
Okay.
So the integral of this entire function would equal x to the n.
Okay.
So then it'd be fair, like the quality stays the same. Okay.
This is just there.
Okay,
It's fine.
for now, just remember you have an integral and a dx sign, because the integral is in terms of x. Okay?
That's good.
you need the dx because it tells you that you're taking an integral with respect to the variable x. Remember that, like that's the important part.
So if you say it was dy, then
Yeah.
Oh.
Then there might be a y here, y to the end. Okay,
I get it now.
that's the important part to get out of this.
Okay.
We're taking it with respect to x. So the integral of 2x, okay? We again go back to this general formula. What is the power on x? 1. So this 2 is a constant. It doesn't matter, okay? So we can just bring that out and make it a constant. X, so the power is 1, so we do 1 plus 1, so we have x squared. Okay? And it's divided by what? N plus 1. So we divide that by a 2 plus c though. So this equals to x squared, which was our original. You always have to do plus c because the derivative of c is a constant. You don't know, yeah.
So like when we get into super ridiculous integrals that take like 2 pages or something like that, at the very end you always have a little plus c.
Yeah.
That's great.
Because these are indefinite integrals, okay? You don't know what interval they're on. They could go on forever. So if we knew, say this was from 0 to 2 or something, then we'd plug in 0 to 2.
Oh, they become definite.
Yeah, and you'd get a solid number rather than a variable. But the important thing that you guys need to know is always this formula.
I'll circle.
It's x to the n plus 1 over n plus 1 plus c.
We probably need to know the squiggly part too, right? This would be x to the n.
This,
X squiggle x n dx equals box.
where?
You're fine. I'm
The integral side?
yeah.
Oh, this integral sign.
Yeah.
Yeah. Okay. So I sort of went through the proof, although they'll do that on the video, and I don't think I explained it clearly.
It's good enough. It was helpful.
Okay.
Oh, I just need the integral just a number, but it's 0. So you x is 0 plus 1 kind of thing. And then that becomes okay. I think I see.
It's the whole idea of this is to isolate x to the n minus 1, which we make x to the capital N. So then when we take the integral of it,
I understand.
we get this is n plus 1 divided by n plus 1.
Okay.
It's like mathematically equivalent.
I don't know what rules and stuff.
Yeah. I mean, there's plenty more when you get to sine, cosine, log, e's.
They did put like cosine stuff like in this video, but it was just like sine.
Yeah, those you just memorize, although they might go through the proofs of them. Or do that way later on.
Is that what we need just on this one, or?
On this test, you will have to do integrals of sine and cosine. Just for right now, I'm going to go through some of the rules. So, two main important parts. You have the integral sign and dx. Okay?
K, F, of X.
Yeah. K is a constant. Whenever we multiply it with a function like this, the constant multiple rule tells us that the constant can just come out. So we have the integral of f of x dx. Okay? The rule for negatives is the same thing. If we have a negative f of x d of x, that's just a negative times the integral of f of x d of x. It's just like the constant rule, just the sign comes out.
Is it like a long, is the integral sign a long S, or is it just kind of like?
It's like a hook.
It's like an f without the middle one. That's the way I think of it. Or I don't know. It could be seen like one of the lines in the violin or something.
Yeah, that holds.
Sure. Okay. There's one more rule. This is called the sum and difference rule. So if you have an integral of f of x plus or minus g of x, and that's being times by d of x, okay? This is equal to the integral of f of x d of x plus or minus the integral of g of x d of x, okay? It's only with plus and minus, now with multiplication division. Okay, like we can do practice problems now with it. Because your next exam will be tough if you've never seen this. Let me just say that. Because you'll need to be really creative and stuff. Because it goes it goes really deep into like thinking, applying the K rule, use substitution. I think you use that on this exam. Yeah, you do. So since you have to leave early, you should definitely watch the end of this.
Okay. I have another like 17.
And go through Khan Academy and all of that.
Okay.
So let's do some small integrals. Integral of 5x dx. What does that equal?
5 times 1 plus 1 plus 1.
So
Is that like 5 times x squared?
yeah, 5 times x squared over 2 plus c. Okay? The integral of x squared dx. X cubed over 3 plus c. Because the 2 at the top plus 1 divided by 2 plus 1. Okay? The integral of x to the 1/2. Same rule. You have x, you have 1/2 plus 1 all over 1/2 plus 1 plus c. That's x to the 3/2 over or times 2/3. You can say that. Okay?
Okay, so it's like
It's divided by 3/2.
x 3/2.
Okay? But that's the same thing as multiplying by 2/3. For those of you guys who haven't done calculus, I would recommend doing a lot of these small problems. Because if you just leave it until Monday night, it's never going to happen. Okay?
Should I go through the book or something? Like I've done actually bought the books.
Yeah.
I've never.
Well, I knew this, so I didn't need to use the book. But I would just say going to Khan Academy and watching all of the videos and doing those practice. But that'll just give you like the frosting of this stuff.
Frosting of cake.
Of a cupcake. The problems that I'm looking at like right now that are going to be on your practice exam also will be at a way higher level.
Let's do one. Let's go for it, David. Let's see how.
Is your next exam 11?
10? It's always like one more than the unit.
I thought it was okay.
Because we got that exam 8, so we just
You gotta get this.
yeah, I don't know. I was like,
You said exam 10?
Yes. It's just always one more. Because unit 1 had 2 exams, so it's kind of everything. I thought they just went to exam 1A, exam 1B.
Yeah.
So that it wouldn't screw up everything.
Yeah. Whenever Dr. Tyler says part A, I want to like part A, or like part
Yeah.
Cause like, that's what we did in our business class, I'm always just like.
Oh. I wonder if the professor should like that. I would be that professor.
Just remember, this unit does cover a lot. You need to know all the box stuff and
The optimization stuff. Okay, Nick.
mean value theorem, induction, which is with summation.
They didn't teach it yet.
Yeah.
Everything on Friday except for optimization. And that one rule that he covered in the last 5 minutes.
So this unit actually covers a lot of tough topics. Let me just say that.
They're like the harder calculations, basically.
So
Yeah.
you're saying this is the exam we'll probably need
No.
to try.
Okay. A lot of students, who've never had calc do bad on this exam.
Great.
You know that now though.
Oh, I didn't know that before.
So,
you can
okay.
expect your
Yeah.
dinner.
So you can work harder.
Oh, okay.
So if I have 1 over x to the 4 thirds. Same rules. So what is happening here?
X to the negative 4 thirds.
So this is x to the negative 4 thirds dx. Okay?
Okay.
That's equal to x to the negative 4 thirds plus what?
1
Plus 1.
plus 3 over 3.
All over negative 4 thirds plus 1. Plus c.
God dang it.
Negative 4 thirds plus 1 is what?
Negative 1 third.
Yeah.
Negative 1 third.
Okay, so it's gonna be like
This is again,
negative 3 over x to the 1 third.
plus c.
So is it-
You lose a point every time you don't put plus.
Oh, I know. I know.
Okay, so negative-
I would definitely say watching and rewatching all of the videos they put on.
why is it
They only have one.
They have one for animals?
One.
Just one? Well, watch it a few times.
Okay.
why would it be negative 1/3 over 3x to the 1/3?
We're dividing by a negative 1 third. That's the same thing as multiplying by a negative 3. Yeah. This is the exact opposite of derivatives, okay? Derivatives, you're bringing down the 2 and then taking 1 away, right? So it's 2x. In integrals, we're adding back the 2. So it's x1 plus 1. And we're dividing by, this was 2 minus 1, right? Then we're doing 1 plus 1 to get back the 2. So this be x squared over.
I know where you were going, but you just got.
No, x.
Did I mess it up?
X to the third.
Yeah, this is being multiplied by a 2, remember that, right? So it's
So then the
2 times all over 2 again. So the 2's cancel out.
Wouldn't it be x to the?
Why do I have a 2 here? That's,
plus?
let me take that out. What?
It's not x for 2 plus 1.
I'm taking the integral of 2x.
Oh.
Okay? It's exactly the opposite, so let me say it again. It's x squared, okay?
Yeah.
When we're taking the derivative of this,
Yeah.
we bring down the 2 and multiply by x to the 2 minus 1. The exact opposite, if we're taking the integral of this, is now it has an exponent of 1, right? So we add back that exponent, and we divide by what we had brought down, okay? Which was that exponent plus 1 again. Like this exponent is 1 more than what it has now, which is that number. So it's exactly the opposite. Here we multiply by the number, here we divide by that number, and we in the end go back to our original, but this time with a plus c. Okay? Am I making sense?
Yeah.
Okay.
I think
Okay. So let me make up a few more problems.
So what do you do with the thing that you're like x squared plus 1 over x? What do you do?
1 over what?
X squared plus 1 over x.
X squared plus 1 over x. That's pretty simple.
It is?
Yeah.
Okay.
That, right?
No, but that's okay. The whole
What-
quantity is x squared plus 1.
Oh, that's pretty simple too. That one you just have to separate.
Okay.
So you do x squared over x and then plus 1 over x.
Yep.
Okay.
Okay. You guys see that?
Okay.
This divided by x is the same thing as x squared divided by x and 1 divided by x. And that being added. So then this quantity becomes x, and this is x to the minus 1. X to the minus 1, taking the integral of that, is a whole different thing.
Did we already do that?
We haven't done the integral of x to the minus 1.
Do x minus 1 third?
Yeah. This is x to the minus 1 though. Okay?
So will that just be 0?
No.
Combined?
No.
Oh,
This is the same thing as the integral of dx over x, because the derivative of x is dx. Okay?
Yeah.
What's the derivative of x?
Oh,
1.
yeah.
Which is the same thing. We normally write 1 because we're doing it in terms of x. Okay?
Yeah.
But the derivative of x is dx, the derivative of y is y prime, which is dy. So this is
Oh, I
1
see.
times
You're
dx.
saying-
Okay?
Okay.
So let me just the derivative of x, if we're doing d over dx, okay, is 1 because we're taking it with respect to dx.
Yeah.
Otherwise, it's dx. Okay? Because that's the change in x. That's the derivative of it. If I have y, the derivative of that is y prime, which is dy. So this is the same thing as dx over x. You have a derivative of what's under it, okay? This is equal to, and I'm sure there is a whole proof, but the natural log of the absolute value of x. Let's see.
This one is on this test.
This might be on this test. It depends on how far they go. I'm not sure if they
I
cover
haven't
that.
watched the videos, but-
I don't know how much they cover in the videos yet. Like, there's a whole bunch of other rules. This is like not even.
So you just put this in.
They might go
But
through
we
a
haven't
whole.
gotten into it yet.
There's a whole bunch of proofs, and
I don't even remember what.
they teach that to you.
Is log-
Not in this unit.
is log E natural log? Is that what it is?
Natural log is with e. Yeah.
Wait, so what's the
The natural log is log-based e of x, which is natural log of x. But you guys don't really need to. I'll take that away. Since dx over x is the natural log of x. Okay? Now looking at this problem. We have x and x to the minus 1. Okay? So what's the derivative of x? Sorry, integral of x.
X squared.
Yeah.
What's the integral of x to the minus 1?
Natural log of the absolute value of x.
The actual value is important, and plus That's the derivative. That's the integral of that. Okay? Now, if this was in the denominator, then that's a whole new.
Alright, let's do that.
No, we're not going to do that.
So, as long as it's not this unit.
Let me see if it's in this unit. We'll do it. Because it covers a whole new topic which you guys need to know. That topic is called U substitution. U substitution is a method of doing integrals. Okay? It's finding a variable u and setting it equal to something with x in order to simplify the problem. Okay? It's sort of like backwards chain rule. Okay? When we have a chain rule, say taking the derivative sine of x squared, okay? Essentially what we always do is we ignore what that is. We just treat it like a u. Derivative of sine is negative is cosine. Cosine of u times du. Okay? So cosine of x squared and the derivative of u would be 2x. Okay? We set u equal to x squared.
You don't have to write du dx. Right there.
No.
You do du.
Just u. And then the derivative of that would be du equals to 2x. Okay? That's like the basic foundation idea of the chain rule. If we have the integral of x over x squared plus 1. Now this will get complicated, okay? Like not as much or as the test will be, but the test will be, it's not as much as what the test will show.
Oh, bonus points.
But we will need to do this. What we have in a we have x and x squared plus 1, okay? We can't break it apart because it's added in the denominator, okay? If we say x over x squared plus 1, x over x squared plus x over 1, these are not the same things, okay? That's a big bad idea. What do you guys think we need to do? What did I say?
U substitution,
U
Daniel.
substitution.
Yeah.
What do you think our u will be?
X squared plus 1 or
It will be x squared plus 1. Okay? So whenever you find u on the side, you should always write your du.
okay.
So what is du? What's the derivative of x squared plus 1? 2x. Okay? We learned, so that's u substitution, okay? Converting that problem into something with a u, okay?
Okay.
That's what we're trying to do. We're trying to convert this problem so that everything is in terms of u, or du. What we learned before is that the integral of du over u, we did it with x, is equal to the natural log of u. Okay? This is what we learned when we had x to the negative 1. That's what we need to do here. Okay? We have the integral. So now we made the denominator a u. Okay? On the top, there's a dx here. On the top, we want a du.
Yeah.
A du is equal to 2x times dx.
So multiply.
We have x and dx. What do we need to multiply by? if we multiply the top by a 2,
Then you have to multiply the bottom
by a 2, which is the same thing by multiplying by 1/2.
Okay, so you just pull out that constant.
We pull out the 1/2 constant.
Let me write this.
Yeah. So this is like where the creative thinking comes in.
Thank you.
Yep. Make sure you really practice this.
Oh, yeah. Over there.
Okay?
Okay.
This is the same thing as multiplying by a 2 at the top and a 2 in the denominator, except we take out the denominator one. Okay? Because now we have what we were looking for, 2x dx on top, which is the same thing as a du. So we can just write du over u times 1/2. Because this is still equivalent. If we were to sub in u and du, we'd have the same thing. So what's the derivative of this? I mean integral.
Natural log,
1/2 times, yeah, natural log of
absolute u.
actual value of u plus c.
Okay, and then you just sub it back.
We sub in for u. So that's 1/2 times the natural log of the absolute value. U was x squared plus 1 plus c. So the derivative of, let me push this up. This is, so do you completely understand that, what we did up there?
Yeah, I think so.
You can repeat it back to me.
So you sub the bottom for u, and then you find the derivative of u.
Yeah.
After you find the derivative, you find a way to set the top equal to du. When you do that, you're going to have to multiply the bottom by the same thing, so you pull out the constant. And then,
Now this is just one way with u, substitution, okay? That's not how, not everything will be natural log.
Yeah.
Yeah, you have to understand that.
it's just that.
Yeah. So, what do you think the derivative of natural log will be? Or let's just put in a u there.
Du over u.
Okay. So if I had the, what's the derivative of the natural log of x squared?
It's just
Well,
dx squared over
2x
so
over x squared, which is 2 over x. So if we were to take the integral of 2 over x, okay?
Yeah.
Did I do it right? No, I think I messed up. Because the integral doesn't. Because there are all of these rules which you guys will one day need to memorize. It should be right. So if we were to do the integral of it, we'd have, oh yeah, I actually works out. What would the integral of that be?
But like,
2
2
times
x
natural log
natural.
of x.
What is a natural log?
Natural log is a log with a base e. Which, like normally we have logs with base 10.
Okay.
That's what our calculators like to work with.
So it means just a number, or
E is a number. Like E is a constant that's irrational. This actually is the same thing as this, because you'll find out this is equal to the natural log of x squared. But you don't need to know.
I'll take your word for it.
Yeah, that's the rule with logs and natural logs. But did you see the process? Yeah.
Yeah.
So now let's actually. Yeah, this problem shouldn't be. No, this is an interesting problem. On the test, you'll have problems where you'll need to break them apart. Like this one we didn't, but if they have the same denominator, or don't forget to break them apart if you have two things on top. But this is a very interesting problem. Say we have x squared over the square root of 1 plus x cubed.
So you do substitution.
Same basic ideas that we covered. Okay? What do you think our u is going to be? Just this part, okay?
Just that.
Yeah. Not everything needs to go to natural log and stuff. Okay? What we're trying to find is, we're trying to find a u in here, which if we take the derivative of, we can lead to some other term. Okay? So in here, we look at 1 plus x cubed. Okay? The derivative of that is what?
3x.
3x squared, which looks like x squared. Okay? So that's sort of how we go about finding our u. So du is equal to 3x squared dx. Okay? So this is being multiplied by a 3. Yeah. So we multiply the top by a 3 and outside by 1/3.
Okay.
This is, so it's equal to 1/3 times the integral of, this is our u, right? We have the square root of a u.
Yeah.
So that's u to the minus 1/2 times du. Okay?
Du. Oh.
This
Okay,
entire,
yeah.
that's du.
Yeah.
So we have u to the minus 1/2. Okay? Don't get freaked out by this, because this is just like an x to a power.
Yeah.
We already did that. So we have 1/3 times u minus 1/2 plus what? So what do we get? 1/2 divided by 1/2
Divided by
1/2
yeah, 1/2.
plus
Oh, yeah,
c.
yeah.
That's equal to
1/3.
2/3, because the denominator is 1/2. Okay? Because this 1/2 goes to the top and becomes a 2.
Yeah.
Times u. What was our u?
1 plus x.
Cubed. So 2/3 times 1 plus x cubed
Plus
plus c. That looks bad, but we made it an easy variable, which is u. We could easily do the integral of u, and then we subbed it back in. That's u substitution. I'll go over trig subs, trig derivatives. With trig, it's not that bad actually, just in the beginning part, because what's the derivative of sine? So what do you think is the integral of cosine? So the derivative of cosine is what?
Negative.
Negative sine. So you asked me about the notation earlier. I'll just kind of throw it to you. We multiply dx across, okay? So we have sine of x times dx equals cosine of x, okay? The integral of it, when we do the integral, is the integral of cosine. What's the integral of cosine?
Wait, so,
This is going backwards to sine.
okay. So, integral is.
Before we do that, let me just show it, and then we'll get. So what's the integral of negative sine of x? Well, let's do the integral of sine of x, not negative. Okay. What's the integral of this sine of x? Negative cosine. What I was trying to show you is that when we multiply dx to that side, okay, and we take the integral of it, the integral and the dx cancel out, and we're just left with the sine. I mean, just left with the cosine.
Integral or
Just cosine. Right? There we go. Actually, it would, yeah. So let me just do that to you. I think you can handle it. So, yeah, it wouldn't be just actually cosine. So we have cosine of x times negative sine of x dx. Okay? This may get a bit complicated, but I think you got it. We do the integral of this. Okay? The integral and the dx cancel out. Okay? So on this side, we have minus sine of x. On this side, we have the integral of cosine of x. I added a dx here because I multiplied by that integral. Okay? What's the integral of cosine?
Is that the proof?
That's sort of backwards working it because it goes in a circle. Okay? This is actually way more than what they're gonna. But do you get what happened here?
I'm really confused about.
Okay, let me.
Multiplication.
Okay.
Yeah.
We multiply by a dx on this side. Okay?
Yeah.
The integral of a dx goes away. So we're just left with minus sine. Okay? But since we took the integral of that side, we take the integral of this side. So the integral of cosine of x is minus sine of x.
Okay. I'm kind of confused how it can cancel out on that side.
We didn't cancel it out on this side.
Yeah. Why?
Because to show you that the integral of it is minus sine. Otherwise, what's the integral of cosine? Negative sine. And that's equal to negative sine of x.
Oh, okay. Okay.
So I'm gonna give you tangent. No, that's not really good. Secant squared. Let's do that. This actually gets a bit tough. So we're doing it, but okay.
Is there no
Yeah. Can we do anything right now?
Can you just assume that it's
I think it might actually get way more complicated than you should see. But what I was going to do is secant squared is 1 over. And then you do the integral of that somehow. You do end up with tangent of x. Because it turns out 1 plus 1 minus sine squared. No, I think that gets way too complicated for you. Trying to find like ways for me to teach this, but instead of just telling you. But what is the? Well, yeah, let's just work with derivative. What's the derivative of tangent of x? Yeah. What's the integral of secant squared? Yeah. At this point, that's fine. Let's not go deeper than that. Yeah. But it gets into messy math, which you can, but we're not going to do that here. What's the integral of cosine squared x? What?
Oh, it's cosecant.
This is cosecant, yeah.
Yeah. So negative cotangent.
Negative cotangent plus c. Because the derivative of cotangent was negative cosecant squared. So just there's a slide in Dino that shows you all of those. And then let's do a problem with it. It might involve u substitution. So okay, let me just go through with you. What's the derivative of integral of sine? Yeah, negative cosine. What's the integral of cosine? Integral of secant squared. Integral of cosecant squared. Integral of secant tangent.
Negative or positive.
Integral of cosecant cotangent.
Negative.
Okay, that's good. It's just looking at it backwards. So now we have the integral of tangent of 2x. Secant of 2x. Secant of 2x. And that quantity squared. It might look complicated at first, but it becomes simpler. Okay? Did I write that? Right? This is actually cubed. Okay? When you get a problem like this, you should know in mind like what's the derivative of tangent?
Secant squared.
Secant squared. Okay.
Yeah.
And secant is tangent times secant. Okay. Secant. We don't know if we're going to use these, but we might have to. Okay? Because we're given tangents and secants. That's the relationship between them. So for this, what do you think our u is going to be?
Secant 2x.
If we try u is equal to secant of 2x. Okay? We can try that.
Or would it be 2x? And you just did
But then we're still confused, right?
yeah.
That goes into the idea of another u substitution.
Okay. So you have 2.
But we can just leave that as an x because we know dx of 2x. What's the derivative of 2x?
No, wait.
2.
2.
Yeah. Okay. So we don't need to worry about that. So we're just gonna guess and say secant 2x.
Okay.
Okay.
So how would you know for sure?
If you've done enough problems, you can get the feel of it. If you can just try them. Okay. But secant sounds like a good point because we know there's a connection between tangent and secant, where the derivative of secant is tangent secant. Okay.
Yeah.
We could have tried tangent and gone with secant squared, but that would have led to an issue because we are cubed. Yeah. But this is a good choice. What's the derivative of secant of 2x?
10
2 times. Remember.
Oh, because yes.
That's what you were saying with u making 2x, but we can handle that.
Okay.
Okay. So we have a u and we have this du. The next step is try to find a du in this problem and a u. Okay? So our u was secant of 2x. Okay? Do we have a du in this problem?
Not that. Well, we have to make.
Well, you should always sort of ignore the coefficient because we can always multiply it by
Yeah.
1/2 or something. Okay?
Just like looking at. I don't.
Yeah. Do we have a tangent in there?
We do. So we have to multiply it by.
Do we have a secant in there? Yeah. Okay? So we have a tangent of 2x. If we had a secant of 2x in there, okay, what would we be left over with?
U cubed? Or
Ignore the u part. If we have just tangent and secant, what are we left with? This is cubed. We took out a secant. What do we multiply it here by?
oh, secant squared.
Secant of 2x squared. Okay? This is still the same thing. But by manipulation, what is this?
The
Almost. We multiply by a 2 and a 1/2. So we have a du. What is this?
U
U squared. So we broke this whole problem into u's and stuff, okay? And this dx is part of du. Part of there. Okay? So then it becomes relatively simple. We just rewrite it in terms of u and du. So we have 1/2 times the integral of what? Well, you always want to do u squared times du. Just a conventional way of putting it. Okay? And you already know how to do the integral of u squared. But the integral of du, that's like dx. So the integral and the dx. Okay? These,
So it's.
yeah. So we just take the integral of u squared. What's the integral of u squared?
2/3.
It's just, oh, wait. It's u cubed. What's in the denominator?
Oh,
3.
3.
Just a, yeah. So, and that's the whole thing is being
Oh,
multiplied by
okay.
1. Okay? Plus c. Don't think of anything else. The integral of u squared. With x squared, we had x to the n plus 1 over n plus 1. Plus c. That's the same thing. U to the 2 plus 1 over 2 plus 1.
So is it
What would that be?
x to the 5th over 5?
It's -6 plus 1. What's
So
that?
negative
Divided by -6 plus 1.
negative.
Yep. So -1 over 5 x plus c.
Oh, okay.
What's the integral of cosine of 2x? That one gets a little bit tricky.
2 sine.
Close. What's our u?
2x.
Du is what?
2.
2 times dx. So if we multiply a 2 here, we need to multiply by a 1/2 on the outside. Okay? So it's equal to 1/2 times sine of 2x plus c. Integral of cosine is sine. We took care of the inside plus c. You could have written here with a u in there, but you don't. Did you do calc in high school?
I did a semester of it, so I think we stopped after. So
That's not calc. That's pre-calc.
it was like a semester of pre-calc and a semester.
Okay.
I recognize most of the stuff.
That's good.
But
Well, I mean, you learn new material. So the integral of 5x to the 4/5 dx. Okay. That's the problem. So we bring the 5 out. We have x 4/5 plus 1 over 4/5 plus 1. Okay. Plus c. What's 4/5 plus 1? 9/5. Okay. So we can rewrite it so that we don't get confused. 5 times 5 over 9 times x to the 9/5. That's equal to 25 over 9 x to the 9/5 plus c. That is pretty much it. I think that's all we're gonna do.
Okay.
So and I wish I could cover some of the other stuff, but this is like the bigger topic that you'll learn. You'll learn induction in this, which is summation of some function like wait, into the k equal to 1 of 1 over 4 to the n or something. And then say 4 to the k. And they want you to prove that this is equal to 1 minus 1 over 4 to the n. That's, you do that by induction, which is like a 3-step process. You do it for when k is equal to just 1, for when k is equal to n plus 1, and then overall. But that's like another topic in this unit. This unit has a lot of topics, including the box topic, which you do need to know because you can do it with volume too.
And then we're gonna do like a box problem and isolation rates.
No, I don't think you guys are going to go that deep. Because, I mean, with the box problem is optimization. So what's the biggest volume? It's not really a function of time.
Yeah.
But that's good.